We're now going to look at differentiating hyperbolic functions. In chapter 1, we did notice that if we differentiated cosh x, we got sin x. Just to remind you about that, here is cosh x. It's a half e to the x plus e to the minus x. If we differentiate the exponential form, we get a half e to the x. Differentiating e to the minus x gives me minus e to the minus x, which is sin x. So differentiating cosh x gives us sin x, and in exactly the same way, we can differentiate sin x. Looking at the exponential form first, a half e to the x, differentiate e to the minus x gives you minus, with another minus makes plus, and so we have cosh x. So our two basic cosh and sin differentiate easily. What happens if we look at tan x? How are we going to cope with that? Well, I hope you're thinking first of writing y equals sin x over cosh x. I think you'll find it easier to do it this way than to write it in exponentials, and getting it out in terms of hyperbolic functions is certainly easier. Now, if we want dy by dx, we simply have the quotient rule. So we write down v squared, cosh squared x v. Differentiate sin x, we get cosh x minus u, which is sin x. Differentiate cosh x is sin x. And cosh squared minus sin squared is 1. And so this is equal to 1 over cosh squared x. Let's make that look a little bit better. And that is, of course, sec squared x. So if I differentiate tan x, I get sec squared x. So we should be seeing a little bit more connection now between ordinary trig functions and hyperbolic functions. Let's look at one more. How are we going to differentiate sec x? Well, the best thing to do is to start off writing it as y equals 1 over cosh x. How are we going to differentiate that? I hope that none of you are actually thinking of the quotient rule. We should really be thinking of this as cosh x to the minus 1 and using the chain rule. dy by dx is now minus cosh x to the minus 2 times differentiate cosh x is sin x. This now is minus 1 over cosh x times sin x over cosh x, which is minus sec x tan x. So again, a lot of similarity between ordinary trig and hyperbolic functions. The only thing that goes wrong is the minus sign from time to time. Okay, we could differentiate coth and cosec, or coshec, and then we would get this set of formulae. For trig functions, we have the ones that we're used to. I should really have written that cosec in red. And that emphasizes that all the co-functions give you a negative derivative. The negatives don't follow over to the hyperbolic functions. Everything else does. Sine to cos, sin to cosh. Sec to sectan, sec to sectanch. Coth to cosec squared, coth to cosec squared. The minuses, the way I remember the minuses on this side is that I think of the three basic trig formulae, sine, cos, and tan, as hyperbolic functions. They're all positive, and the other three are all negative. So that's my own method of remembering which is positive and which is negative. Here's a simple little example. If we have y equals cosh 3x squared minus 1, how can we find dy by dx? Well, you should all be able to do that. dy by dx. Chain rule, if I differentiate cosh, I get shine. So this gives me shine 3x squared minus 1 times differentiate 3x squared minus 1, 6x. Tidy it up, 6x shine 3x squared minus 1.